In this question, it is given that the value of this whole integral is dash. You have to fill in the blank where box denotes greatest integer function. Actually, it seems to be a very lengthy question, but actually this question can be done just in 20 seconds. The only thing is you must know this concept. In this question, I'll be using this concept that box minus x plus box x is sure to be equal to minus 1 if x is not an integer and 0 if x is an integer. This formula I'm going to use in this question. First, let me calculate the first part. That is, for first part I'll be getting 64 by pi by 6 to 5 pi by 6 box cosec x dx. We know that the graph of sin x in the interval 0 to pi is this. Pi by 6 is somewhere here, pi by 2 is somewhere here, 5 pi by 6 is somewhere here. This point is 1 by 2 and this is 1. As x increases from pi by 6 to pi by 2, the value of sin x increases from 1 by 2 to 1. That is, in other words, I can say the value of cosec x will decrease from 2 to 1 as x increases from pi by 6 to pi by 2. And similarly, as x increases from pi by 2 to 5 pi by 6, the value of sin x decreases from 1 to 1 by 2. In other words, I can say as x increases from pi by 2 to 5 pi by 6, the value of cosec x will increase from 1 to 2. That is, in other words, as x increases from pi by 6 to 5 pi by 6, because the value of sin x remains between 1 by 2 and 1, therefore the value of cosec x will remain between 1 and 2. Hence, this question becomes 64 by pi by 6 to 5 by 6 and 1 dx, because the value of cosec x is lying between 1 and 2, therefore box cosec x will become 1. But you may be thinking that cosec x can become equal to 2 also, because the cosec x lies between 1 and 2, therefore box cosec x will be always 1 except at when x is pi by 6 or 5 pi by 6. Otherwise, the value of cosec x is always 1. Ignoring the points pi by 6 and 5 pi by 6, I can write it as 1 dx. But you will say, why I have ignored pi by 6 and 5 pi by 6? For complete explanation, you will have to see my video lecture of definite integral. But the main concept I tell you here is to make you understand the reason of ignoring pi by 6 and 5 pi by 6. I will explain in this way. Suppose fx is some function and it has value, say x square plus 4x plus 1 for x lying between 1 and say 5. But x is not equal to 2, 3 and 4. But if x is 2, 3 or 4, in that case the answer is 0. And suppose the question says that find the value of 1 to 5 fx dx. It is 1 to 5 fx is x square plus 4x plus 1 dx. I can ignore the points 2, 3, 4 and directly I get the answer. The answer will be correct. That is, I just want to tell you that suppose in some question as x varies from here to here, the value of fx abruptly changes at some discrete points. We can always ignore those points. There is no harm in ignoring those points. Answer will be always correct. And the complete theory why ignoring points creates no problem for us. For that you will have to see my video lecture of definite integral. Same thing is here. At pi by 6 and 5 pi by 6 the value of cosec x is 2. But at all other points the value of cosec x is lying between 1 and 2. And therefore box cosec x will be 1. That you will be getting 64 by pi into x and pi by 6 to 5 pi by 6. And we'll be getting the answer 64 by pi into 4 pi by 6. That is 128 by 3. The same property I am going to use in second part of the question also. For second part of the question, first I am calculating the value of pi by 6 to 5 pi by 6 and box cot x dx and I am naming it as I. And this implies that I is equal to pi by 6 to 5 pi by 6 box cot 5 by 6 plus pi by 6 minus x dx. That is, I have used the formula of a to b fx dx equal to a to b f a plus b minus x dx. This implies that I is equal to pi by 6 to 5 pi by 6 and cot pi minus x is minus cot x and dx. And now if I add these two, I'll be getting 2i is equal to pi by 6 to 5 pi by 6 box cot x plus box minus cot x and dx. That is, I get 2i is equal to pi by 6 to 5 pi by 6. And just now I had told you the formula box minus x plus box x is minus 1 if x is not an integer and 0 if x is an integer. Hence I can say the value of this will be usually minus 1 except at those values of x for which cot x is an integer. That is, in other words, usually it is minus 1 except at some discrete points, because usually it is minus 1, hence I can say minus 1 dx. Ignoring those points when this can become 0 also, hence the value of this is minus 1 and I get I equal to minus 1 by 2 5 by 6 minus pi by 6 that is I'll be getting minus pi by 3. Hence I conclude that the value of this becomes, note that the value of first part was 128 by 3 and the value of integral of this part only is minus pi by 3. I have calculated 128 by 3 minus 40 upon pi into minus pi by 3. That is, I get 128 by 3 plus 40 by 3. That is, it is equal to 168 by 3, 56. Hence the answer is 56.